Hello everyone. Today I'm going to show my few weeks of research work on the diffusion models. So the first one will be the text to image generation. So the text to image generation is basically we give a text and then the image needs to be generated. So I'm using the UNet here. This can be done in different ways. You can use variation autoencoder. You can use the GAN, but I'm using the UNet because I want to test the DDPM sampler. So the DDPM sampler is basically doing the forward and the reverse process. So in the forward process, we add a lot of Gaussian noise. And the reverse process, we just remove the Gaussian noise and then based on the time, we generate the image. So in on top of it, I just added the text. So the user can say, I want to generate a cat image. It's not the text is not going to be user friendly because I'm just using the label here. So I am trained on the CIFAR dataset. So I just use the CIFAR labels to generate the image and also to showcase the DDPM samplers working. So this is the model we have, and then we're gonna run the DDPM sample on the model. So it's already trained on the CIFAR labels. So it's going to create images like this. So I'm using the DDPM sampler to generate a dog. So I already hard coded the prompt here. So we can actually put a input uh, Python library to get the user text and then generate it. To showcase the demo, I just hard code here. Right. So now it generated a sequence of image. Uh, So that CIFAR data set is basically 32 cross 32. So we cannot exactly see this is dog or cat or anything like that. This can some anything can be dog here, but this is not a real image. This is kind of a realistic image that the model generated. Uh, so to confirm this is a dog or cat or frog or anything else, I already trained a ResNet. So the ResNet has an accuracy of 73% because the CIFAR data set is very, very small. The ResNet has the accuracy of 73% to predict whether the trained image is dog or cat or anything else. So we run the same here using the ResNet as the classifier to predict whether this is cat or dog. All right. So now we generate the image and then the classifier is telling us the first one is dog and then it's a frog and then it's a cat. Um, so based on that, it's trained on the CIFAR label, the classifier is, and then it's predicting these images based on the label trained on the ResNet. Uh, so this is a very, very simple workflow of how to do the text to image generation using the diffusion models. The second one will be introducing the diffusion into the large language model. So currently, ChatGPT uses autoregressive. Uh, to confirm that, we can ask ChatGPT what type of decoder is it using. So it uses the autoregressive decoder. So if you know autoregressive decoder, it's basically a sequence of tokens generated uh, one after the another. So the diffusion model decoder uh, is not used here. So we're going to show a demo here and examine how fast the diffusion model decoding uh, for 1000 tokens compared to autoregressive decoding for the 1000 tokens. So I'm going to run the autoregressive decoder first and see how fast it's generating 1000 tokens. So this is trained on the Harry Potter dialogues. So I'm gonna ask Harry, how are you? And then see. So it generated 1000 tokens in 4.55 seconds. So we will go to diffusion and then see how fast it's generating 1000 tokens. Yeah. So this generated 1000 tokens in 3.5 seconds. So this is 1 second faster compared to the autoregressive. And the grammar is completely wrong here. It doesn't get the context. It doesn't know what it's speaking. But you can see the word formation is somewhat right because this is trained on 20,000 iterations. So it needs a lot of training, a lot of iterations in training. So autoregressive is trained on 5,000 iterations, but it got the context uh, more quicker and it's more richer compared to the diffusion models. Diffusion models needs a lot of iterations in training to understand the context uh, and the grammar. But the generating of tokens here is much more faster. And I want to show you my another demo. Previously, I have shared speech to text model. So now I have upgraded it. Now I add another feature to generate an image. So now you can give a sentence and then it will generate an image. So this does not use GPU. So this is hosted in Hugging Face, first of all, and this does not use GPU. This uses a CPU to run the inference loop. So when you give audio, it will take some seconds to generate the image. So let me show you a demo. So I have uploaded an audio that says the quick brown fox jumps over the lazy dog. So now it's transcribing and generating the image. So you can see here it got the conversion right because the audio says quick brown fox jumps over the lazy dog, and then it got the image somewhat right. But here the lazy dog is missing, but you can see here the fox is kind of jumping. That's what the image says. So yeah, feel free to test this link out. I'll share below this post. Thank you.